I'd like to welcome everybody. My name is Reece. I and my colleague Ray Selesky, who was just speaking, we host the AI and Telecom Meetup, previously located in the Plano, Texas area, now all around the world. Not hyperbole at all, huh, Ray? I want to thank you guys for attending.
No, not at all.
You know, Ray is definitely he's waiting for the bars to open up.
No, it's already open.
Yeah. So Ray and I both work for Ward Solutions. We're a host of the meetup. We have a third partner in crime, Beverly Ibarola, who's not joined us today. She may join us a little bit later. A little bit about Ward Solutions. We're a technology training partner with the world's best networks. We were supposed to go to Barcelona in February prior to a lot of the challenges we're dealing with this year. As of right now, we're hoping to go to LA in the September-October timeframe for Mobile World Congress Americas. We don't know. We have started up our complimentary webinars in AI and automation, and the next one is on May 15th, which is a little over a month away, and it's on AI use cases. It's actually based off of one of the webinars or one of the meetup presentations I gave about a year or so ago as well. So complimentary, please feel free to sign up for that. You're more than welcome to. I will try to remember to post a link on the meetup page. As always, you can reach out to me. I'm going to actually put this in the chat, creece@awardsolutions.com, as well as you can find me on LinkedIn. If you do reach out to me in LinkedIn, do me a favor and tell me that you met me via the meetup, so that I will accept your invitation. So what I wanted to talk about this month was generative adversarial networks. And there's a lot of different types of AI. I got fascinated with this over the last few months, and I've had an opportunity to play with it a little bit. It's a very interesting type of AI. And what I wanted to do is I wanted to kind of talk about what it is, what problem it's trying to solve. I want to show you a small example, and then I want to show you a couple of things you can find on the web of how they're using these generative adversarial networks. And what makes this interesting is this term adversarial, in my opinion. What makes an AI algorithm adversarial? And actually the adversarial part is the interesting part. So we'll talk about what a GAN is. We'll talk about the GAN architecture, and we'll talk a little bit about use cases. Super high level. We're not going to be able to cover a whole lot in, you know, the 45-50 minutes that we have here. Please ask questions. Feel free to jump on the bridge. Feel free to jump in the chat, whichever you're comfortable with. But please, part of the reason we wanted to move this to Zoom was so that it was more interactive. So please take advantage of that. I have a number of references, and I will send out a link afterwards where you can download this presentation. But there's a number of different tutorials that talk about GANs, as well as some background articles on GANs. So a generative adversarial network, we can think of that as really being composed of two different components, and that's what this chart is trying to show. This is a graph that comes from the Asimov Zoo. If you've never seen the Asimov Zoo, it's a based off the Isaac Asimov Institute, named after Isaac Asimov, the famous science fiction writer, who really created this concept of artificial intelligence. It was him in a science fiction context that created this concept of a machine that could think like a human. That's really where this artificial intelligence comes from. And so at the Asimov Institute, they have drawn pictures like this for a number of different types of networks, a number of different types of AI models. What we'll see with this adversarial network, and that's really what's coming here, is this is where that adversarial piece comes in. You can almost think of it as two different networks. We have something that's trying to learn to create, and we have one network that's trying to learn how to discern, which I'm probably going to spell wrong. So if we think about this from a human perspective, if I wanted to decide one day to become a great artist, I want to be a great artist like, I'll use Andy Warhol, as Andy Warhol was an artist, and I wanted to become the next Andy Warhol. What I would do is I would paint a painting. And I would go to Ray, who is an art critic, and he knows and lives and breathes everything that has to do with Andy Warhol. And I'd say, Ray, look at this painting. Does this look good enough to be an Andy Warhol painting? And he would look at me and he would say, no, it's not. It's not good enough. And I would go back and I would take all these Andy Warhol paintings and I would put them all over my room and I'd study them and I would create another one. I'd say, Ray, how is this one? And he would say, no, it's not. Well, if we could continue to do this long enough, I could learn to create something, maybe, that could pass as an Andy Warhol painting. That's really what the generative adversarial networks are trying to do. We're trying to create something to where we learn, right? So we're doing machine learning, so we've got learning here. Learn how to create something that passes that as something else. Right, so there's a couple of pieces to this. We've got the creation piece, and we've got the learning how to train, how a model could think it was something other than what it really is. One of the best examples is human faces. If I were to create a model that says, is this a human face? Could it pass as a human face or not? Okay. So that's the problem that a generative adversarial network is trying to do, is it's trying to have kind of these two models, one that's a creation engine and one that's more of a discerning. So there's a number of different high-level use cases, and why would I use GANs? Well, one way is to do generating new data, and this is the example that we're going to look at a little bit today, is how could I generate a new piece of data? Another is maybe do some form of privacy. And then lastly, some form of data manipulation, which is kind of what I'm showing here with Fluffy. So you see the upper left-hand picture, what that was a picture. There's Ray with his Andy Warhol background. One was a picture of Fluffy. And then I took another image on the right, and then I was able to apply that style to the image that I had taken. So let's think about this from more of a AI perspective. So first, pause. Questions, comments, thoughts? Kind of the problem that we're trying to solve. Does that make sense?
Yeah. Hi, Sanjeev here. Can you
Yes,
elaborate
Sanjeev.
a little bit more on the privacy point? That was a little unclear.
So from a privacy point of view, is what I can do is I can try to create an algorithm that allows us to hide data. And again, I'll be perfectly honest. As soon as I said it, I knew I was going to get myself into trouble, because I see this as one of the use cases. I haven't researched how to do that as using GANs.
Yeah, that's fine. Thank you.
Yeah, no, but it's a great question. It's a great question. And really, to be perfectly honest, it was one of those things. What got me interested in GANs was the generating data, was the new image, the new thing. And kind of what reaffirmed me wanting to talk about it is I was actually watching a couple of weeks ago, Microsoft had their global AI boot camp. And so if you're, it was great. I watched a couple of the a couple of the webinars. So let me put it in the chat, Global AI Boot Camp. And so if you look for that, you'll find it. And all their videos are online. Somebody did one on LSTM, long-term, short-term memory, a system that was generating text. And she started talking a little bit about GANs. That's what kind of made me think about doing this. But really, it's that generation of data. That's the part that I find interesting, is kind of more of the creating side. And I was doing a little research on this last week, and I don't have the reference off the top of my head, but somebody trained a model based off of a number of paintings by a specific artist. And then they had an AI algorithm create basically new models or new paintings. One of these have sold for a large amount of money. So we think about some of this AI generated art. GANs are what's doing it. AI generated music. GANs are what's doing it. So yeah, you can do, oh, so Photoshop can do something similar, Donna's saying. What's the difference? Well, one of the big difference is if Photoshop's doing it, it's me manipulating an image in some way. Kind of like what I'm doing here with what's on the screen. I made the decision that I'm taking Fluffy and this style image and marrying them together. Now, the AI algorithm actually did the marrying and created the picture down here at the bottom, but I was the one that made that selection. When I'm talking about what a GAN is trying to do, at least from this generating data, it's really from the perspective of nothing existed before. We're trying to create something completely new and say it passes off as this family of whatever. And let me show you an example. I'm actually gonna, I was gonna save this as a use case towards the end, but let me go ahead and show you now. There's a website called This Person Does Not Exist. I'm gonna put that in the chat for anybody who's interested. So this is a website that has GAN created, Generative Adversarial Network created faces. And if you look at these faces, you'll say, this looks like a real face, but the more you look at it, it just doesn't seem perfect. And so this is of a young boy. You can see kind of in the lower right-hand corner, this is imagined by a GAN, created December of 2019, and it has all the information about that. If I go and I hit refresh, here's another image. Every once in a while, you'll find some that just seem to have a lot of extra artifacts, things that just don't look right. you know, here's a good one. You've got kind of these extra artifacts that are kind of down here at the lower portion of this child's face. It almost looks like the head looks like it's looking to the side, but I don't know, it just doesn't look right to me. So that's an example. It's creating this new image. This person really doesn't exist, but it's created this person based off of learning how to create something that looks like faces. And I'll talk about what that means here in a second. So do you see kind of the difference, Don? Don, I think now again, Photoshop, Adobe, I'm sure they're doing some great things, but what they're really trying to do is say, let me take a picture and let me make it look like something else. So I, as the human being, am really the artist. Adobe is a tool that I may be using. With a GAN, the hope is that the AI algorithm itself is the artist. And I've seen some really interesting groupings of these faces where you'll even say, like, you look at someone, it's like, that guy's an actor. I've seen that guy. That guy was in that movie. And it's just that he has these stereotypical qualities of a leading man actor, but he's not really, it's not really a person. All right, so that's a little bit on kind of that use case. And then Gabriel put in the chat a Fast Company magazine article. I'm going to share it with everybody. What you look like as a Renaissance painting according to AI. Whoops, I basically put it privately back. Let's do this. Okay, now everybody can see it. So yeah, there's a lot of really cool things like that. And so I think that stuff is fascinating, personally. All right, so let's look at the architecture. Let's kind of see how this thing actually can happen. So we're going to divide our network into two networks, two different types of models. One network, we're going to call him, and this is a very common analogy. I see a lot of people using this analogy. We're going to call him the art critic. And what he's going to do is he's going to learn by looking at a number of real images of whatever it is that we're talking about. He's going to learn how to be able to predict real, fake. So that's what the discriminator, that's what the art critic is trying to do. He's trying to go and look at an image that's generated and say, is this real or is this fake? Now my artist, his job is to create an image. Now wait a minute. Can an AI algorithm really create anything? Not really. Right? It's not really creating. It's not really looking at that and saying, I wish I think her eyes are a little bit too close together. Let me try to make her eyes a little bit farther apart. Or I see that there's no, it's not looking at an image and judging it in that way, right? Because a computer only sees pixels. It only sees patterns in those pixels. So what it's going to do is it's going to randomly generate noise. And then it's going to take that noise and it's going to feed that into the discriminator and say, hey, is this a real picture? And we'll say, no, it's fake. And then it's going to evolve. It's going to try, and it's going to try, and it's going to try, and it's going to try. And over time, it's going to learn what it takes to fool this art critic the discriminator network into saying this is a real image or not. So the adversarial part really is coming in right here. I'm predicting, is this real or not? So I'm trying to create one network that's going to create, another network that's going to predict, and then I'm going to learn how to create images through trial and error, through brute force approaches, until I come up with things that are better images and then better images. It even kind of feels a little bit like reinforcement learning in that regard, where I'm going to try and get a score and try and get a score and try and get a score. So that's the high level view of a generative adversarial network. Let me pause at that point and see questions, comments, thoughts.
Hi, Sanjeev again, sorry.
Hey,
Should the response of the predicted label real or fake go to the fake images or to the generator network? Because the fake images are the output.
That's fair. Fair point, fair point. My arrow should probably go here.
Thank you.
Yeah. Yeah, absolutely, absolutely. Because really the two networks are here and here. And as a matter of fact, let me see. Okay, so yeah, let me pause. I'm going to go through a very simple example. Any other questions or comments on this? So I want to start with a simple example, right? Because it's, you know, the people who are doing like the this person doesn't exist, I mean, they've been working on this a long time. So let's come up with something simpler. So what I thought would be good is let's use MNIST. And if you've spent any time within the AI space, the machine learning space, you're probably familiar with the MNIST problem. Originally, what the MNIST problem was is it was a problem that came out a number of years ago trying to come up with a machine learning approach to read handwritten digits. And this particular problem, what they did is they took 70,000 hand-drawn digits and converted them to 28 by 28 pixel grayscale images. So not high def, not a lot of pixels. It was a fairly simple thing. And so what the original MNIST problem was to say, how can I learn through looking at these 70,000 images, how to determine that that's a 5, that's a 0, that's a 4, and that's a 1. That's what I'm trying to learn. So what I'm going to do is I'm going to take this example and I'm going to kind of twist it. What I want to do is I want to say that this is my real data. This is my real images. And what I want to do is I want to come up with an AI algorithm that can generate hand-drawn numbers. So my discriminator network is going to learn what a real hand-drawn number is from looking at these images here. And then I'm going to feed it from my generator network new images. And it'll tell me, is it good or is it bad? So let me I'm going to kind of show you a couple of things here. This is kind of the end of the story. What we see on the left, this was the first generated image. Now you tell me, what does that look like on the left? Noise, nothing. Yeah, exactly, Kieran. It looks like nothing because that's what it is. It's randomly generated pixels. What we see on the right is examples of what this generative adversarial network has learned to do over the point of 50 iterations, 50 epochs. So it learned from the left to examples on the right. And they're not perfect, right? Let's be honest, right? I mean, when I look at the ones on the right, those do not look like really good hand-drawn images. Everything seems a little fuzzy. Everything seems a little this one that's this one right here, I'm not really sure what number that is. You know, so it's creating things that don't actually look right to me, but this is after 50 epochs. What if we would have let it run 100 epochs? What if we would have let it run 1,000 epochs? But that's kind of the point. And actually, I've got a really cool graphic here. So this is it learning. And so you can see it's a little tough to see the animation, I think, over Zoom, but hopefully you can see it's just kind of learning. It's kind of, it starts with kind of this blank canvas and it kind of starts to learn a little bit. So what is this? So let's take a look at the model itself. I don't want to spend a lot of time getting into that depth of the model, but let me, so I'm gonna go here and I want to go here. So let me kind of show you, and this is based off of an example. That was one of the examples I have as the in the reference. It's based off of a tutorial that's on TensorFlow's website. And the first thing I want us to look at is this is the generator network. And what it's doing is it's trying to adjust the pixels based off of feedback that we're getting from the discriminator network. And the image it's starting with is that image that I've already shown you, this just random set of pixels. Okay, so that's the generator network. That's the generator network. The discriminator network is actually more of a standard convolutional neural network model. So what it's doing is it's learning, it's kind of finding the edges, doing some normal convolutional layers so it can determine what real is. So that's our discriminator network. We're doing a binary cross entropy, which basically is saying, is this real or fake? It's really only doing a binary calculation. It's not doing anything more sophisticated than that. We're generating a loss based off of that. And then we actually start to do the training. And the training does take a while. And so if I kind of step down here a little bit, it doesn't show it here. No, I had a, I thought I had something that had time. On the virtual machine that I'm running this on, it takes about 6 to 10 minutes per epoch. And so I was, you know, and I have 50 epochs, right? So 400, 500 minutes. So it was taking a number of hours to train this. And I could have added more epochs and I could have gotten better results. Let me come back to here. So I think this is the interesting one. So that's really what a GAN is trying to do. That's really what a GAN is trying to do, is to have these two networks. And the reason this is such an important thing is, think about this for a second. And this was actually something I didn't come up with. I wish I could remember her name. She did a talk at the Global AI Boot Camp on using recurrent neural networks to generate a better ending for Game of Thrones. That was her talk. It was a great talk. I highly recommend her talk. And at the end of it, what she started to talk about was, imagine a world where we could have an AI algorithm learning from basic types of other things how to generate something new. So the example that she gave was, instead of using images like I'm talking about here, what if you were to take and create a romantic comedy? And so now I've learned what a romantic comedy is. And if I could train an AI algorithm to create a romantic comedy, then what it would be able to do potentially is to actually generate that entire movie. Obviously, we're not there yet, but that's an interesting thing to think towards in the future. And that's one of the things I found interesting in this scenario. Okay, so let me pause for a second. Questions, comments, thoughts? Because what I want to do for the last few minutes is I want to look at a couple of examples.
This is great. Thank you.
Okay, good. Excellent. Can you tweak the algorithm? Oh, can you tweak the algorithm parameters on how you want to merge the different pictures? Don had put this a while back and I missed it. Sorry about that, Don. When you're looking at that style transfer, yes, the style transfer is, again, a whole host of different things that you can do. And one of the things that's happening within style transfer is, if you look at a convolutional neural network, there are different filters that you apply. And based off that filter, you're gaining different types of information. And so you can apply a filter at a certain point to potentially do that sharing information from one image to another image. And so not going to go into that today, but style transfer. If you look at style transfer, you'll find a lot of great stuff. And there's some great tutorials there. And where I got AI Fluffy here was following one of those tutorials. And but it's a really interesting thing. And this is something that's been around for a while. I actually first heard about this style transfer a few years ago. And then GANs is kind of taking that a step further. Now, I don't have an example of it, but if you do a little research on the internet, you'll see a similar type of animated image as, over the course of a number of years, them refining some of the GAN algorithms on faces. And I found that really interesting, because if you start to look at some of the how good they were in 2014 and compare that to 2018, it was a pretty significant difference. It was pretty impressive. All right, so we've already talked a little bit about this person doesn't exist. So, and I grabbed this picture specifically. Now, every time you do a refresh, you get a different picture. And so I did one that had some artifact in it that I wanted to include as part of the presentation, and I ended up stumbling across this one. And this is a great example. Obviously, something wrong is going on here. This has passed the discriminator network saying that this is a real face, but you'll notice we have kind of that. I'm not sure what that is, other than an artifact that was somehow learned. Maybe it was because some faces had other faces next to it, and so therefore the algorithm learned that it was okay to have this other face there. It's something that's a problem with the discriminator network. I don't really know, but every once in a while, kind of like this one that we saw, actually, we saw it here. Like this one, that just something doesn't seem right with this picture to me. Right? I mean, I don't know if it's that the shirt doesn't seem right or the head seems twisted too far. I'm not sure what it is. It's something doesn't seem right to me. But every time you hit refresh, it's going to download another picture. This is another good one that seems to have something wrong with it. I mean, the face itself looks fine, but what's with this kind of fuzz on the side of the face here? So, I mean, you see what I mean? Is it just doesn't quite look right. I also noticed in a lot of pictures, the earrings didn't seem to match. Yeah, and that's a good observation, is it's not learned some of those subtleties, right? The algorithm learned earrings are okay. One earring is okay. Two earrings are okay. But it didn't really learn, you know, that they needed to match. You'll see some that have different color eyes. You'll see some that that just, you know, like if you look at the pupils of this one, the pupils seem really big. So I mean, it's really kind of an interesting thing. And then this, like I said, this kind of half fuzz thing on the side is weird. Yeah, here's a good one, because the ear and whatever this thing in the hat seem to kind of be the same thing. So this is another good example of just something doesn't seem right. But these are pretty good, right? I mean, what is your opinion? Give me a green check if, I mean, you know, most of these are kind of believable, right? I mean, if I were to take a picture and let me see if I can find, this one isn't bad. So if I were to use this as a profile picture, if you were to go to my Facebook page and you were to see this, you had never seen me before, and this was my profile picture, would you think twice about it? No, I wouldn't think twice about it. That's the guy's, you know, he's you know, kind of looking at the shirt he's wearing. It kind of looks like a rugby shirt. The guy is kind of athletic. He looks like he plays sports, and I wouldn't think twice about this being a profile picture. And so that's one of the things that some people are starting to do, and that's another thing that kind of interests me in this, is they'll create a fake Facebook account, create a fake Twitter account, and then they'll use this as the profile picture. And I'm not going to get in trouble from stealing somebody else's Facebook picture, or I'm not going to, if I don't want to have my picture and I want somebody else's, I'm not picking somebody else. I'm not going to have somebody go and say, hey, that's my brother, why are you using their, in this case, so this is my sister's picture, why are you using my sister's picture on your profile? So it's just kind of an interesting thing. Now, one other thing that's kind of, and this is going to get a little bit weird, so just to let you know, this is actually a really good picture. I like this. There isn't anything You know, yeah, if somebody had this as their profile picture, I wouldn't think twice about it. I don't know about you. In the lower right-hand corner, there's a few interesting little things. One of them is this artwork doesn't exist. So this is the same group of people who did this, and now what they're doing is they are using a similar algorithm to create abstract art. That is completely generated by an AI algorithm. You can play the same little game. You can do that one I don't think is all that great. No. I mean, I could totally imagine walking into a doctor's office or into a hotel room and that being on the wall. So that's kind of interesting. And then one more. That cat doesn't exist. So these are going to be AI generated, GAN generated cats. And so this one doesn't look too bad. And if you're a cat lover, I apologize for some of the AI generated cats you're about to see. That one looks pretty good. I'm not sure what's going on with that one. Yes, these are actually pretty good. Yeah, that one, I'm not sure what's going on. That's a good example of one it's like a cat body with a head popping out of the middle of it. All right, and we've already talked a little bit about the style transfer as well. All right, excellent. Other thoughts? Questions, comments, thoughts?
Hello?
Hey, Ashley.
Comment about the romantic comedies.
Yes.
The using the AI for first drafts would be actually pretty cool. So that's the part a lot of people don't like, the white paper issue. But the bad in the editing, I'm not sure that the AI would handle the editing any better than it handled the fuzz around the cats. And
you're absolutely right.
I've seen that fuzz problem before with trying to Photoshop cats when making book covers.
So I put in the chat, there's a organization called Botnik, B-O-T-N-I-K, and that's kind of a play on the term beatnik, the old artists from the 50s and 60s. And they have they do a lot of stuff within the LSTM space, the long-term, short-term memory space, where they're doing AI generated fan fiction. And they have a newsletter that comes out every couple of weeks. And in it, they're doing, what they've done is they've pulled in all of the works of J.K. Rowling. They're big fans of Harry Potter. They pulled in all of the works of J.K. Rowling, and they are writing AI generated Harry Potter fan fiction.
I've heard that.
And what they do is kind of what you're talking about. What they do is they actually have the AI algorithm write the first draft. And then they have a human come in and clean it up.
Yeah, and it's in the cleanup where the magic is.
And actually it's really kind of it's a very interesting approach that they've taken, because what this allows them to do is the weird stuff that the AI algorithm can come up with, the weird stuff stays. But now it's complete sentences and you have proper punctuation and proper capitalization, all of this stuff that that for us human beings is really required that the AI algorithm isn't learning. So you're absolutely right, Ashley. And there are people looking at that if you're doing text generation, it's a little bit different than the GAN. GAN is really things that are more on that visual side is what I've seen so far. And LSTM is more of that text side. So if you could create something that kind of marries those together, you might have something very powerful. This whole concept of a GAN is only a few years old. I mean, this is a really new thing. And it really, from what I understand, I can't remember the name of the person who came up with the concept, but what he did is he was just, you know, basically at a bar one night saying, hey, wouldn't it be cool if you could have, you know, two AI algorithms compete with each other and come up with something? And that's kind of where the GAN concept comes from. And so no, I mean, it's a cool concept. I really like it, and I want to play with it more. And we're starting to see AI generated art being sold for, I don't know if it's millions of dollars, but you know, it's being sold. So maybe that's a very interesting thing that we could come up with as kind of a you know, a way of you know, I come up with a Patreon account and you can buy some of my AI generated art, right? I mean, I don't know. So that's pretty much what I had for today. I appreciate everybody joining. We'll hang out for a little bit if we want to chat, but I know people probably do have, even though you're not driving back to work, you probably do have to get back to work. So next month, we're also going to do it online. I'm going to be posting this in Meetup over the next couple of days. And actually, it's kind of, the timing is good. Ron Chichester, I think is how you pronounce his last name. He came to a couple of the AI meetups when we were still doing them face-to-face, and had a lot of people talking to him about kind of the legal side of AI. He's a patent lawyer, and he does have a background in AI, and his specialty has been really where AI and the legality come into the picture. And so he has done a presentation a number of times. He said he would speak to us next month on understanding bias, privacy, and legality associated with AI. And so I hope you'll join us for that next month. It'll be really a different slant on AI. So let's take this GAN for a second. So could I generate a picture using a GAN and take ownership of it? Who's the owner of that image? Is it me, or is it the algorithm itself? And if it's the algorithm itself and the algorithm is published, does that make it public domain? So these are our very interesting discussions. But anyway, we'll be here on May 18th at 11:30. As I said, on the 15th of May, we'll have the AI use cases. I'm going to hang around if anybody has any more questions, but I just want to thank you for your time. Hopefully this has been valuable. If it has, you know, let me know. If you've got a topic you want to cover, send me an email, send me a chat, reach out to me on LinkedIn. If you would like to speak at this, reach out to me. We're always looking for people to speak at our AI meetup. But thank you guys so much.
Thank you.
Thank you, Molly. Thank you, Jean.
This was very helpful.
Thank you, Ashley. Thank you, Sanjeev. Thank you, Jean. Thanks, Karen. Those of you who come for the first time, thank you. Come back.
Thank you. Thank you.
Thank you. Thank you, Morris.
Thanks, Chris.
Thank you. Take care.
See you next time. Bye.
See you later. Stay safe, everybody.